All right, so we're now going to do 3 sample questions. We're given the following sets. S, the set of positive integers less than 20. So S is going to include positive integers would start with 1, 2, 3. That's going to continue all the way up until less than 20. So that would include the number 19, but not actually 20. So that's the universal set that we're starting with. We're given A is 4, 5, 6, 7, and 8. And B is the set of prime numbers contained inside of S. So B, who remembers prime number definition? I had to look it up last night. Anyone remember? Only divisible by 1 itself. I remembered that. Does it include 1 or no? It does not. It starts at 2. So 2 can be divided by 1 and 2, 3 by 1 and 3, 5, 7, 11, 13, 17, 19. I think that's the set. So A union B, A and B, we're going to start with our lowest number 2, 3, 4, 5, 6, 7, 8. And then continue on with B, 11, 13, 17, 19. Okay, if it's contained in either A or B, we include that in the union of A and B. And then here we have A intersection with B. So it's got to be contained in both A and it has to be inside of B. So is 4 in? 4 is not inside of B. 5 is inside of B. 6 is not inside of B. 7 is inside of B. So that's it. Those are the only 2 that are contained in both A and B. And so now to draw our Venn diagram, I'll show that this one is A, this one is B. Inside of the intersection, we've got 5 and 7. Inside of just A, we've got 4, 6, and 8. 1 is in neither, so I'm going to remember S is our universal set. So 1 is on the outside, 2 is inside of B, 3 is inside of B, 4 is in A, 5 is in both, 6 is in A, we've already done that, 7 is in both, 8 is in A, 9 is in neither, 10 is in neither, 11 is in B, 12 is in neither, 13 is in B, 14 is in neither, 15 in neither, 16 in neither, 17 is in B, 18 is in neither, 19 is in B. I literally was counting through that whole set from 1 to 19 and just checking to see where each one was. Any questions on that? I don't think it's challenging, but you do need to pay attention and literally, kind of be marking off. You may have noticed up here as I was doing my A's, I was kind of checking them off with just a little dot as I went to make sure that I'm counting each number. Can we go on? Okay. Here we're going to see some new representation. Here we have the letter NA. And so that's talking about the number of elements inside of our set. Okay, so N for number. We're not actually concerned with the fact that the number is a 2, a 3, and a 5. A 2, 3, and a 5, there's actually a total of 3 numbers there. So it's the number that are inside of it. So given the following sets, S spells the word keyboard, A is E, O, and A, and B is the word board. Draw a Venn diagram illustrating the relationship between the sets. So again, S is our universal set. We'll take A and B here. going to be a little bit confusing. Let me do this differently. S, A, and B. I don't want to get confused between the subset A and the letter A that is inside of the subset. Okay, so my sets and subsets are being marked in red. Inside of set A, we've got E, O, and A. And I can see that O and A are common to both. So I'm going to put my O and A at the intersection. My E is in A. So I've now dealt with all my A's. My B's are going to be the B, R, and D. That's a D, not a P. And then outside of S is the word keyboard. So key has not been included yet. E is inside of A. Y is not included. And then board has been taken care of because that's all contained inside of B. Any mistakes so far? Am I right? Please do point them out if I make mistakes. So the following, A, Devin, what's that A apostrophe? Remember the word for that? You look fabulous today, Devin. You look great. What do we call that A with a dash? Complement. So the complement of A is everything that's not inside of A. So we've got everything that's not inside of A is the K, the Y, and then the BRD. All right, that's not inside of A. The B primed or B complement is everything that's not inside of B is going to be the word key. Notice that I can't just say the word key. I do have to separate all three letters by the commas. Sarah, when I've got this upside down U, do you remember what that refers to? Intersection, great. We might also remember that it's like A and B. So what is contained in both A and B? That's the intersection. That's going to be O and A in this case. And then A, U, B, that's the union of B. So it means it's inside of A or it's inside of B. So I'm going to write all of the elements there. And now, Lorraine, do you remember what I said, the NA, what that refers to? Number of elements inside of A. So inside of A, this entire circle, there are 3 elements inside of that. The number of elements that are going to be inside of the union of A and B, right? So I'm looking at the number inside of here. We got 1, 2, 3, 4, 5, 6. And the number that are inside of B primed, I figured out what my set of B primed is. There are 3 elements inside of there. I'm not sure if I should be calling it B primed. That's what I do call it, but it's the complement of B. Do you know? Does anyone know? Is it B primed? Is that okay to use? That's what I call it, but I'm not 100% certain that we should, but we could definitely call it the complement of B. All right, given the following sets, last question. We've got A is 2, 5, 6. B is 1, 3, 5, 7. List all the subsets of A. So what are all the possible groupings we could have inside of A? So A, we could have just a 2. We could have just a 5. We could have just a 6. We could have elements with 2. We could have a 2 and a 5. We could have a 2 and a 6. We could have a 5 and a 6. We could also have all 3 elements, 2, 5, 6. And we could have nothing. We could have the empty set inside of A. And then finally, all the